In this video, we're going to do a nice triple integral question. So we are given that f of n equals n squared for all integers n. And we want to find the value of the integral from 0 to 1, of the integral from 0 to x, of the integral from 0 to x, of the third derivative of f, plugging in x plus y plus z, and then first with respect to z, then with respect to y, and then finally with respect to x. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, we're going to start with the inside. So that would be the integral from 0 to x, and we're going to do it with respect to z. So you can think of this as parentheses. So say parentheses from there to there, and that's what we're going to evaluate. Okay. So the integral of the third derivative of something is the second derivative. So this would be the second derivative of x plus y plus z. And now we have to check the derivative of the inside, and in this case the derivative of the inside is 1, so we don't have to worry about dividing by anything. So then we're going to plug in from 0 to x. When we first plug in x, we get f double prime of x plus z. So this is z equals 0 to z equals x. So when z equals x, we have x plus x, which is 2x, plus y. Then we have to subtract the lower bound, so that's f double prime. Z goes to 0, so this will be x plus y. Okay. So now we're going to integrating with respect to y. So now what we're doing is another parentheses here. Okay. So for the first one, we have the integral of the second derivative is the first derivative, so f prime of x plus 2y. But in this case, we have to divide by 2 because we have 2y, and derivative of 2y is 2. Then we have minus f prime of x plus y, and we don't have to divide by anything. Now we're going to plug in from y equals 0 to y equals x. Okay, so when we plug in y equals x, we're going to get f prime of x plus 2x, which is 3x, all over 2, minus f prime of x plus x, which is 2x. Okay, so now we're going to do minus. So now we're going to plug in when y equals 0. So when y equals 0, we're going to get f prime of x all over 2, and then minus another f prime of x. Okay. So let's look at this. So we have f prime of x over 2 minus, so we can make this 2 over 2 because that's not changing anything. And now we have 1 minus 2, but that's negative 1, so we can get rid of this part. Okay. So this will be 1/2 f prime of 3x minus f prime of 2x. And then we finally have minus minus, which is plus 1/2 f prime of x. Okay, let's write that down. So now this is the final integral. So that's the parentheses. Okay, so how do we do this? So similarly, we're going to integrate term by term. So the integral of f prime of 3x will be f of 3x divided by 3, and then you can multiply the denominator, so that'll be over 6. Then we're going to have minus f of 2x, then we have to divide by 2. And then we're going to have just 1/2 f of x, because there's nothing, the derivative of x is 1, so we don't have to divide by anything. So we're going to plug in from x equals 0 to x equals 1. Okay, this will be f of 3 divided by 6 minus f of 2 divided by 2 plus 1/2 f of 1. Okay. Now, by the x equals 0, so x equals 0 will give us something like some c value, some constant times f of 0. But we know from the beginning, f of n equals n squared. So what we have is f of n equals n squared. It means that f of 0 equals 0. So these terms will just go to 0. So we don't have to worry about x equals 0. Okay. So now f of n equals n squared for integers n. All these are integers, so 3 squared is 9 over 6, 2 squared is 4 over 2, and then 1/2 times 1, because f of 1 is 1. Okay, 9 over 6 can simplify to 3/2, because divide by 3 on top and bottom. 4 over 2 will be 2, and just 1/2. The nice thing is 3/2 plus 1/2 is 4/2, but that's equal to 2, and 2 minus 2 equals 0. And that is the answer to this question, and that's the end of the video. Hope you liked it, and thanks for watching.